So it is going to be module 4, force and motion. Here we are going to define that how force and motion are two dependent terms. So as far as the mechanics is concerned, in the mechanics or in the first part of the mechanics, that is motion in one dimension or along a line, we studied that how motion takes place. What are the factors that are responsible? What are the quantities that changes? So we talked about each and everything in detail. But from today's onwards, we'll talk about it how motion is actually caused. So basically, we're going to talk about the cause of motion, which is known as force. So before defining what is force, let us see few things related to the advancement in understanding how force causes motion. So in order to understand this, you need to first of all understand the fact that it is not something which is being discovered like way back in last year, 10 years ago, 100 years ago. It is the efforts of different scientists over a different time period, over a period of thousands years, I can say. That much time zone or that much difficult it was to study all of these. So here comes the first person who actually talked about it is called Aristotle. So Aristotle
Yeah, I know.
gave something called Aristotle fallacy. What he said is that he just observed what we observe generally. Like he said, if something is in motion, so after some time, what will happen to it is that it will comes to rest. So he simply said that in order to keep an object in motion, there is a constant force required to keep it in motion. This is what he said simply. Like this is a very basic thing. Anything, if you just roll it down over the surface, it will come to rest. Why? Because uh, there is something we can say that there is some force which is required to keep it in motion. This is what Aristotle thinks. So a basic observation, and because of that basic observation, we actually got one way, or you can say we actually got a line to think about that how this whole branch of science deals with. So according to Aristotle, he simply said that in order to keep an object in motion, in order to keep an object in motion, we need a constant force. We need a constant force. Then only it will continue its motion. Otherwise, what happen? Otherwise, it will comes to rest. Otherwise, it will comes to rest. So according to him, he simply believes that in order to keep an object in motion, there is a force that is required, and if we have that force, that object will come. That object will continue its state of motion. So this was the first advancement in this, you can say, journey of understanding physics. Then here comes another scientist named Galileo Galilei. So what he said is it is a completely different thing in comparison to what Aristotle said. Although the time difference between both of them is like a very huge. Aristotle gave that statement about in 1900 AD, where Galileo gave his studies in 1600 AD, we can say. So you can almost see the difference between the time zones is almost about 700 years. Like in order to understand physics to a greater extent, we need to first of all understand that whatever scientists have done so far in physics, it's not something because of the one person. It is because of all the persons who just keep on thinking and their curiosity just pull them in such a way that they are figuring out that why this is happening. So
Mhm.
Galileo, after keeping his interest, a lot of interest in understanding motion and everything, he just came to a he just came to a conclusion. But before actually understanding that what he concluded, let us understand that how he came to the conclusion. So what he did is he just used a plank which is inclined at some angle, and he polished it. He polished it like literally very smooth. He just made it very smooth. So what he did is he just dropped a object from the top of the inclined plane, and he found that when this object comes to the bottom, after covering a certain distance, it comes to rest like that. So he tried something different. What he did again is he made the surface smooth again, onto which the object is going to move. And the remaining surface he kept rough. So this is the rough surface, this is the smooth surface. The surface of incline as well as from where the ball is going to strike the surface, they both are smooth. So again the same thing he did. He dropped the ball, and what he found this time is if after reaching at this point, it doesn't slows down. It keeps on moving till this point, till the rough surface came. Now it's starting slow down, and after covering a certain distance, it comes to rest.
Mm.
And the last, what he did is he just kept the whole surface smooth, like super smooth. He just did some of his carpentry skills and make it super smooth. And because of that, he again did the same job. He dropped an object. When the object came to this point, he gets some velocity, and he keeps on moving with that velocity until the smooth surface is there. So, based upon all these experiments, he came to a conclusion, and he concluded that an object will keep in motion or at rest unless until an external force is applied. So, the statement which he gave and the statement which Aristotle gave, they were completely opposite statements. On the other side, Aristotle was saying that in order to keep an object in motion, a constant force is required, whereas Galileo said in order to keep an object in motion or in its own state, there should be no external force acting on it. If there exists an external force, its state of motion or the rest will change. Like how he can say that? Because when the object reaches the rough surface, there is a small force of friction which start acting onto the ball or the object, which slows it down and make it to the rest. So it's not something that we are applying. We need to apply the force in order to make it in motion. It's just like that. Whenever there is an object and it is in contact with the ground, there must be a force called force of friction which try to oppose it. So according to this, the statement is completely correct, and from here, the whole origin of mechanics came into the picture. This is the first turning point for the this complete, we can say, field of science, where we are actually thinking about motion. Before that, no one was actually talking about motion. What matters to them is that they made a wheel and now they're easily able to transport things. This is the only thing they were having and they were utilizing. After that, when we got to know all about motion and all the factors that are affecting motion, the whole world is completely changed. Today, we are observing supercars around us, trains, metros, and even something that goes under the sea. So there are a lot of things going on around here. But how all these things came into existence because of the curiosity of that one person who just figured it out that motion is something or the object will continue its state of motion unless until an external force is applied. So in order to keep that object in motion, we are sometimes using that external force or sometimes that external force is helping us to stop the object. So few factors are there which are actually helping the object. So from this particular part only, we define few different terms that are completely important to understand forces and the motion. So here comes the one word which is known as inertia. So inertia is nothing but it is a measure of mass of the body. Like for example, suppose there are two objects and they both are moving simultaneously with same speed, I assume. So suppose there is a wheel of a car and it's going with some velocity v having mass m. Similarly, there is a truck It is also going with same velocity having mass capital M. So as far as their motion is concerned, we can say that the body having more mass possess more inertia. So the inertia of truck is going to be more than the inertia of car. So inertia is basically a property of an object which defines that how much motion it can actually possess. And that is something which is depending upon that how much mass it actually carries while traveling. So this law later on, or this statement later on, turn out to be law of inertia. So whenever a force is acting onto the body or of the object, it actually changing its state. So when it actually changing its state, it's actually changing its inertia. So we can say, and this is something which is found to be the law of inertia. So the object will keep in motion or will keep in state of rest unless until an external force is applied onto the object. This is what Galileo says, and later on this one becomes the law of inertia, becomes the first law of motion as well. After that, we define one more term which is called momentum. So momentum for any object, it gives the measure of quantity of mass. Like what does it mean? It simply means that suppose there is an object having some mass m, so its momentum is given by product of mass and velocity. The important part here is this momentum is a vector quantity, and we discussed each and everything related to the vector quantities. So whatever we have learned so far regarding vector quantities, momentum will follow the same. Momentum can change for different change in velocities, and momentum do have direction. And when we talk about the direction of momentum, it is same as that of velocity. So whatever velocity or whatever direction velocity has, momentum will be in that same direction. If we talk about the unit of momentum, it can be kilograms meter per second. So we also need to remember this. Now here comes a very simple question. Let's say there is a bicycle of 12 kgs moving with 20 meters per second, whereas there is a car I assume to be of 100 kgs, 1000 kgs moving with 1 meters per second of velocity. So the question is which possess more momentum? So as we already know that momentum is mass times velocity. So momentum of cycle is going to be 12 times 20, which is going to be 240. Unit is going to be kilogram meters per second. Whereas for car, momentum is going to be 1000 times 1, which is equals to 1000 only. That is 1000 kilogram meters per second. So here we can clearly see that the momentum is greater for car in comparison to great for bicycle. So it is something which depends upon two quantities that a body possess. One is mass, other is velocity, and here we are observing both of them. In this section of unit, or you can say in this module of unit, we are actually going to define that how force affects the motion of the body. Like for example, we already discussed this thing. Suppose there is a body, and this body is having experiencing force in this direction. So
Wait,
what will
could you
happen to the
switch the
object?
last slide for a minute, please? Yeah.
Yeah.
Mm, okay.
So let us assume that there is a force acting on an object in this direction. So after some time, if we observe what will happen, the object must have moved through some distance and its velocity also have changed. So initially, if I assume that it is moving with 2 meters per second, so finally its velocity might be changed to 12 meter per second because of the action of this force. So here what we found is that there are different type of force that might exist. And these are the types of forces we are defining on the basis of the motion. So types of forces defining on the basis of motion are simply of two types. What are these two types? They are simply balanced forces and unbalanced forces. As the name suggests, balanced forces are something because of which the net motion of the object is supposed to be zero. Whereas because of unbalanced forces, there must be some net force, and because of that net force, object might be moving in certain direction. So let us try to understand each and every type of forces in detail. This will leads to another concept called concept of equilibrium. We'll understand that as well. So I assume that there is an object of mass m, and in this object there are two forces acting. One is acting in positive x-axis, another is acting in negative x-axis. I assume that the force is acting in the positive x direction is supposed to be 7 newtons, whereas the force which is acting in the negative direction, negative x-axis is also 7 newtons. So here, if we try to figure it out, that what is the net force acting on the object. So how we are supposed to find it out? We'll simply say it is going to be equals to force acting in positive x-axis minus force acting in negative x-axis. So net force will come out as 7 minus 7, that is 0. So whenever the net force acting on an object is 0, we'll simply say the forces are balanced. So this is the primary condition for balanced forces. Similarly, if I just change the example and I assume that the force acting in the positive x-axis is more, like here it is acting 10 newtons, whereas in the opposite direction it is acting 5 newtons only. So here I keep the mass same as m. So here what we can observe here is that the F net that we are going to calculate, it is going to be Fx minus F minus of x, where minus of x is simply representing that the force acting in negative x direction. So Fx is going to be 10 newtons, whereas F minus x is going to be 5 newtons. So here we can say that there will be a net force of 5 Newton acting on the object, but in which direction? It will be acting in right direction because the magnitude of greater force is acting in right direction, so it should be in the right direction. And we have already seen that how we are supposed to represent the direction of vectors using I, j, k cap. So here I can say the net force here acting is going to be I cap, that is 10 I cap newtons. So here for unbalanced forces, here comes the condition. For unbalanced forces, F net is not going to be zero. This is the only thing that we need to understand about balanced and unbalanced forces. If F net acting on the object is zero, then we will say that the object is in balanced state or the forces acting here are balanced. Whereas if we see that the force, net force on the object is not equals to zero, it simply means the object is experiencing unbalanced forces. And because of these unbalanced forces, there might be possibility that it will be experiencing or it will be going under some motion. So if I want to explain balanced forces to a greater extent, I would simply say if net force acting on the object is zero, object will continue its state of motion, will continue its state of motion. And that state of motion can be any, like it can be at rest initially. So if the balanced force is acting, it will stay at rest. Or there is another possibility that it can be in variable or it can be in constant motion or uniform motion. So if it is in uniform motion moving with a constant velocity, it will keep on moving with that uniform velocity. Why? Because the net force acting on the system is zero. Net force acting on the object is zero. So this is how we actually define balanced forces. And whenever the forces acting on an object are balanced, we will say that the object is in equilibrium. We will say that object is in equilibrium. So this is the name which is given to the condition when F net acting on an object is zero, object is in equilibrium. This is what it means. Or we can
Wait, so
also say that
What does it
Yeah.
mean if two vectors are equal? Because that was one question on my test that I didn't know what to do. If it was asking find the equilibrium of um a minus b. So wait, a plus b equals negative c, right?
No, no, no. It depends upon the vectors, like how they are
Oh,
acting. You need to show me the direction, like in which direction vectors are actually acting, and because of that, we'll say that which is going to be the equilibrium condition. So,
okay.
in order to do, we'll definitely figure out few
All
questions
right.
based upon this, so you'll be able to know this. And you are saying that the question of on equilibrium is being asked on the basis of velocity, like by considering velocities, right?
No, it wasn't considering velocity. It just said find the equilibrium of uh so I originally did a minus b. I got I graphed the vector of that and it said find the equilibrium of it was a vector, it wasn't related to velocity.
Okay, let's understand it, or you'll be understanding it very soon. We'll be talking about laws of motion. You'll understand what there it was actually needed.
Okay.
If I try
When I
to
get
make
back
you
to test,
understand,
can we just like review it?
yeah, when you are going to get it,
Probably early next week.
all right. So let us understand this condition for balanced forces. For balanced forces, we say that net force is going to be zero. Now, according to second law of motion, net force is defined as rate of change of momentum. So rate of change of momentum is, if it is zero, it means momentum is going to be constant. And if momentum is going to be constant, it means that the final momentum must be equals to initial momentum, or we can say the change in momentum is going to be zero. So when the question is saying what is the equilibrium condition, so for the condition or for the system to be in equilibrium, product of velocity and mass initially and finally should be same. So if initial velocity is equals to final velocity, that is the condition where we say that the object is in equilibrium. Similarly, if object is at rest initially, so finally also it will stay at rest. So that condition is also called equilibrium condition. So these are the two things that we need to understand. So finally, Vf is also going to be zero. That means object is again going to be at rest. That condition is again supposed to be of equilibrium condition. So these are the two things that you need to remember about equilibrium condition. Either the object will be stays at rest, either the object will be moving with constant velocity. No any other thing is possible. Whereas if we talk about unbalanced forces, equilibrium condition, condition of rest, or condition of constant motion, or object moving with constant velocity. Here we can be zero, but here we should be constant. So both, if both the conditions are there, it means object is having equilibrium state. Whereas if we talk about unbalanced forces, so unbalanced forces are those forces for which net F net is not going to be zero. So we will simply say if the net force acting on the object is not zero, it means object must be moving, object must be moving with changing velocity. That is the main difference. If it is balanced force, velocity will remain same. If it is unbalanced force, velocity will change. So ultimately does the momentum. That is what we need to understand here. So velocity will change and we can say F net is not equals to zero. So we can say rate of change of momentum is not going to be zero. So momentum final is not equals to momentum initial. And what is the condition? When we actually observe this, when there is some acceleration. So whenever there is any acceleration on the system, whenever there is any acceleration, in the system, we can simply say the forces acting are unbalanced. We can say the forces are unbalanced forces. So that is what we need to understand about balanced and unbalanced forces. That is what we need to understand about how they are going to affect the motion. Does this make sense?
Mm-hmm.
Once you'll be understanding the same lesson in the class,
Mm-hmm.
then everything will be very helpful to you, or you can say you'll be able to answer so many questions quite
Mm-hmm.
easily.
Okay.
Let's move ahead. So here we understand that the force is something, or we can say that we can define the force as, so force is something which is directly proportional to rate of change of momentum. So force is defined as rate of change of momentum. We can also define the same thing as like force is push or a pull, but this is something which we use to define it in English, but in science we define it as rate of change of momentum.
Mm-hmm.
So it says that the force, which is a vector quantity, it's supposed to be delta P by delta T, where delta P is what? Delta P is change in momentum, whereas delta T is what? Delta T is time. So whenever a force is acting on an object, the first thing we observe that its velocity keeps on changing. Like, let us understand the same by an example. So I assume that there is an object. It is initially moving with some velocity u. Now what happens here is that some external force starts acting on the object, because of which after some certain time when I observe the position of the object, it changes and its velocity also changes to v. I consider the mass of the object to be m, and during that motion, it must have covered certain displacement s. So we can find out each and everything here using the law as well as equations of motion. Let us try to do that. Suppose at this time time was supposed to be 0, but at this point time is supposed to be some t. So here, if we define force, so force is something which is defined as rate of change of momentum delta p by delta t. What I can write about delta p? Delta p is going to be p final minus p initial. Whenever we are writing change, so change is something which is defined by final minus initial. So always remember that. So here F can be written as P final. What is going to be P final? Mass into velocity. Mass into final velocity. What is P initial? P initial is equals to mass into initial velocity. I would say. Divided by T minus 0, that is 0, that is T. The force can be written as mass times V final minus V initial by T. Now let us try to memorize the first equation of motion which we have studied in the last module. So what does the first equation of motion says? The first equation of motion says V final is equals to V initial plus AT. This is something I have written from first equation of motion. Just remember one thing, whenever you are studying physics, whatever you have studied before, everything need to be remembered. If by any chance you forgot anything, then it will be difficult to understand the next
Mm-hmm.
concept. So from here, acceleration can be written as Vf minus Vi over t. So if I substitute the same value of Vf minus Vi over t in this equation, so what can I say about force? Can I say that force is nothing but mass times acceleration? So here we not only need to understand that how equation will be solved, but we also need to understand that how the relation came which we are using to solve the problem. So the force which we are using, which we are going to use in upcoming classes as well as solving upcoming questions, F is equals to mass times acceleration. This is how it came. It came through the statement, or it came from the definition of force. So force is something which is defined as rate of change of momentum. Because we have seen it, force is something which actually changes the momentum of the object. So when anything is being changed by something acting on it, so we can define that physical quantity based upon what it actually changing. So here you came to the conclusion that force is nothing but mass times acceleration. Now let us try to understand that what are the nature of forces, what are the forces actually present in this nature or our surroundings. So next is going to be types of forces based upon the material which, or you can say based upon the nature. On the basis of motion, we have defined balanced and unbalanced, but on the basis of, we can say nature of the force, we will define types of forces. That is going to be the next topic. Let's talk about it. So types of forces on the basis of their nature. Like for example, so here in physics we have categorized forces in four categories, or you can say we have defined forces, or you can say the fundamental forces that are present in nature are of four types. First is gravitational force. Second, we defined as nuclear force. And nuclear force are itself of two types. Before that, we defined electromagnetic forces. Electromagnetic forces are itself of so many types. We'll talk about it. Then, on the basis of their nature, we have also defined force as weak nuclear force and strong nuclear forces. First, we have weak nuclear force, and second, we have strong nuclear force. Now, let us try to understand what each type of force is. So, gravitational force is something which acts between the two masses. It is attractive force, the only force present in the nature which is attractive in nature. It is the force which acts between the two masses, like we can assume Earth and Sun. The force which is keeping Earth aligned with the motion along with Sun is something we call gravitational force. Similarly, there then it comes electromagnetic force. So, in order to understand electromagnetic force, just remember a magnet. So, magnet can both attract as well as repel. So, electromagnetic forces are attractive as well as repulsive. They can attract as well as repel. Whereas if we talk about weak nuclear forces and strong nuclear forces, these are the fundamental force which actually let us sustain the whole world or the whole universe. So basically the force which acts between nucleus and electron, we call it as strong nuclear force. Sorry, weak nuclear force. Whereas the force which is acting between nucleus and protons, it is something we call strong nuclear force. If these two forces are not there, atom will not be stable, and if atom is not stable, the whole world will not sustain. So that's why these all are the fundamental forces, and these are the forces which are found everywhere in this universe. If there is a mass, there is a gravitational force, and if there is a mass, there is a charge, and if there is a charge, there will be electromagnetic force. And if all of these are there, then there must exist a weak nuclear and strong nuclear force. So these four forces are the four forces which exist everywhere in the universe, and we will understand each and every force in different units. Gravitational force is again something we'll learn in different unit. Electromagnetic force is something we'll learn in electricity and magnetism. Weak nuclear force and strong nuclear force is something which we will study in modern physics. So we'll understand each and every type of force in the upcoming units. But here we need to have the introduction of all these forces. Now, the thing is, if we don't want to study these forces here, why we are talking about it? Because the forces which we are going to study here are nothing but electromagnetic force and gravitational force. We'll talk about some of the gravitational force, we'll talk about some of the electromagnetic forces that might be there in the system. So, in order to solve different problems here in mechanics, we have different type of forces that exist in our surrounding and affecting the motion of the body which we are studying. So what are these type of forces? The first we have is weight. Yes, weight is a force. Then we have a force called normal reaction. Then we'll talk about gravitational force or gravity to be precise. Then we'll also talk about here spring force. Apart from that, we'll talk about friction force. Apart from these five forces, we have another two forces that we will study in circular motion called centripetal force and centrifugal force. So all of these forces are the forces that we are actually going to see that they are going to affect the motion of the body or the object. But centripetal and centrifugal forces are those forces which exist in circular motion and they actually affect the motion by keeping that object in circle. And if these two forces are not there, we might not be see a circular motion anywhere around us. So these are the main forces that we will be focusing in all the classes. Similarly, we will see another term here sometimes resistive force or drag force. So these two terms are not the different one. Resistive force or drag force is something which is used to define friction only. Friction is something which actually opposes the relative motion between the two surfaces, whereas resistive force and drag force are the same. But the system change is observed. That's why the name we have changed from friction to resistive or drag force. So we'll talk about that also. Or in order to understand these two things, let us consider a simple example. Suppose there is an object of certain mass. What we did here is we just dropped it. Because of the mass of the surface, because of the mass of the object. First of all, it will go down because of the force acting on it due to gravity that is supposed to be mg. But because of the air present in the surrounding of the object, there must be some another type of force that might be acting onto the object when we are dropping it. Like for example, just assume that there are two objects, one is paper ball and another is iron ball. If you drop both the balls, which ball will hit the ground first? Are you listening to me?
Yeah.
So I'm asking if I have two balls, one is made up of paper and another made of iron. I drop two balls from the same height, which will hit the ground first.
Iron.
Why?
Because its mass is more.
Because it's mass more. Also, we can say that the drag force which is going to act on the paper ball will be more than the drag force which is going to act on the iron ball. So, drag force and resistive force are nothing but they are the situational forces. We will deal with them in certain conditions, not always. And whenever we are talking about drag force and resistive force, they are simply friction, nothing else.